Hello, everyone. I'm Roger Struckoff. I'm in charge of research here at the International Data Center Authority, or IDCA. You are now in the data center arena. Thanks for attending today. And over the next hour, we're going to talk about five of the main issues that are affecting data center, AI centers, and everything that goes with it. We are joined today by the chairman of IDCA, Mehdi Pariavi. We are also joined in alphabetical order by Peter Gross, who is one of the better known people in the entire industry, involved in lots of boards and including sitting on one of the IDCA boards. We have another board member, Greg Sly, who's SVP, I believe, of infrastructure at CrowdStrike at the moment. Also a very, very deep background in the industry. And by Mark Thiele, who is a co-founder of Edge Vana. Did I say that correctly? I believe I did, and is now pursuing the things he's been pursuing for a few decades in this industry. They're all on the leading edge of innovation, but we mostly want to talk about today the practical aspects of what's going on. Everybody knows what the major issues are. Everyone who's attending this, and we thank you for your time. We're going to tell you what you should be doing right at the moment. So let's first get a brief summary of what that is that's going on from Mehdi.
Good morning, Roger and everyone. I think we're living in interesting times. The industry is expanding both vertically and horizontally in every direction. You can talk about the energy play, you can talk about the AI play, you can talk about the workforce, you can talk about policy, you can talk about governance, investments in every aspect. There are challenges, there's opportunities, and nobody's talking about percentages anymore. Everybody's talking about multipliers. Um, and the thing about this is a lot of these expansions are all substantiated by contracts, backed by contracts. We are today in the largest industry in the world. Last year, we surpassed oil and gas industry by $40 billion. $580 billion went to the data center industry. Everything we do on day-to-day basis, whether it's the things we do on Facebook or on LinkedIn or ChatGPT, they're all driven in and out of data centers. Data centers are the engine behind the digital economy. Digital economy is foreseen to be taking up over 30% of global GDP by 2030.
Yes.
And none of us would be where we are or even having this webinar today if it wasn't because of data centers. So we are in a very interesting time, and we have experts, specialists, and celebrities in the industry today with us. So hopefully we can have a nice conversation.
Okay. Before we start in, and let's get a quick survey of what our audience is interested in today. It may inform our discussion a little bit. I believe our producer has some questions in the background. So if we could launch the first question from the poll, that would be good. What will be the primary driver of global data center demand over the next 5 years? And you've got four choices. You got to choose one. That's the whole thing. We all know each of them is important, but let's choose one and see what kind of result we get. And also, what Media just said, that the investment in data centers now has exceeded that of oil and gas. Oil and gas was probably the leading investment attraction in the world for decades, and now we've this industry has surpassed it, and we see it. That's the new trend. It's going to surpass it for years and years. And I'm not sure how quickly the results come up here. I think it blinks, and then I think, yeah, there we go. Okay, AI. People want to talk about AI. Cloud computing expansion. Cloud computing, of course, was yesterday's story. It's become so inherent that now people are really concerned more about AI. And let's ask the second question, and then we'll jump into the discussion. Which challenge poses the greatest obstacle to data center expansion today? Power, and again, you have to choose one because we all know what the issues are. We really want to know what's the most important one to our attendees. Power, regulatory, the workforce challenges, or financing. We could offer a secondary market, betting on what the answers are with AI these days, but we probably won't. But it wouldn't surprise me if one of our attendees is already doing that. That's how sophisticated we're getting. Pretty soon this will blink off and the results will come up, and then I'm going to Yeah, power. That's what I would have bet on. I'm gonna call Las Vegas now and see if I can do it. Yeah, power. That's what people want to talk about. The other things are certainly important issues, but power, power, and power. But before we get to that, let's turn to Peter and talk about innovation. Peter, you've been in the industry for a long time, as have we all. You've seen things develop over the years, all the major developments. Would you say that right now, though, is the most dynamic, fast-moving era of the data center industry? And if you agree with that, why and how is it moving so quickly?
Yeah, thanks, Rogers. I had the privilege of being in this industry for a long time, so I've seen it all. I've seen mainframes and distributed and in the internet and cloud, and I can tell you, nothing comes even close to what we're seeing today. It's
Yeah.
um, you know innovation doesn't come easy in this industry, primarily because it's all about reliability and uptime, and it's people are there is not for the longest time there was not a lot of incentives for innovation. So obviously the data center have obviously improved over the years, but improvements were incremental. Obviously, you
Yes.
saw better, more efficient components, more reliable, lower footprint. I mean, they're all improvements, but they're incremental, nothing fundamental. If you compare a data center design in 1995 to a data center design in 2018, 19, you won't see a lot of difference. There are some different topologies, there are a few other components, but essentially it was the same architecture until three years ago, and these things called AI came around, and all of
Oh,
a sudden the whole game has changed fundamentally. You know what they say? Necessity is the mother of invention. And
yes.
if you come to so what drives innovation? And there are three factors here, and they are obvious. One is technology. This is what is the main factor. Physics and economics. These are changing. These are the elements that are changing our industry. And um, the the things that we are seeing today are absolutely unheard a few years ago. My first data center I designed a few years, a couple of years ago.
Yeah.
It was for one of the financial institutions in New York City. It was a nice 1 megawatt data center. 1 megawatt data center, and today in a few years we're going to have one cabinet
With a
uh,
megawatt in it. Yeah.
running at 1 megawatt. So, so uh, what are the pain points and what are the external threats of this industry? And it's a long list, but if you look at how the architecture, the topology, the geometry of the data center have changed, and I'm going to list here just a few of the main innovation and changes that are re uh, dramatically reshaping this industry.
Sure.
So it's all driven by size and density. As we move from Hopper to Blackwell to Rubin,
Right.
Rubin Ultra at 600 kilowatts or so, to Feynman, one megawatt. All these changes, the rapid changes, we're talking about 2 3 years of refresh, are uh, are imposing extraordinarily difficult choices in terms of design, construction, and operations. Um, it's um, the fact that we are transitioning now from AC to DC, from conventional 480 volts or 415 volts to 800 volts DC, or
Right.
plus minus 400 volts DC. This is not a trivial change. I mean, you look at the implication of a change like this, we're still not there yet. We can provide 800 volts DC, and there are tools today and equipment that can provide that. But still, we still don't have circuit breakers operating at 800 volts DC. We still have to be concerned about arc flash and protection, selectivity, coordination. All these things still need to be resolved. But we're still marching in that direction. Why are we doing that? I mean, there are a number of reasons for that, but just to give you a sense of the need to go to higher voltage is if one would design and build a data center using conventional architecture, the traditional architecture we use for 30, 35 years or so, the amount of copper used for a design like this will exceed 55,000 tons. I mean, this is one data center. This is 1 gigawatt data center. I mean, that's a lot of copper if we come to think of it. And that's one of the reasons the price of copper has increased almost 30% in less than a year. So how are we going to do that? Well, we're going to go to liquid cooled busways, or there are discussion about transitioning from 3-phase distribution to 6-phase distribution, or what my favorite solution is going to be is using hot superconductivity. This is the property of materials to operate with virtually zero resistance. So you're going to run 10 times more currents through the same diameter wire. I mean, this is one example of necessity driving innovation. Then we have the issue of power fluctuation. I'm sure you're all familiar with the operations of AI data centers, where you have tens of thousands of GPU running synchronized, and this model of operation creates an extraordinarily unique and different power profile, where you're going to have transitions from 20% to 160, 150% of the provision power and oscillation within 50 milliseconds periods.
You mentioned physics and all of these tremendous issues that are coming in engineering, but you also mentioned economics. So how does that manifesting itself when we start looking at the actual financing, construction, and operations? Because they're tremendously large issues you're describing.
Well, obviously the numbers are staggering, and Mehdi mentioned that before. We transition from kilowatts and hundreds of thousands of dollars to megawatts and millions of dollars, and now we're talking about gigawatts and billions. So it was a very rapid transition, and each one increased the numbers by by thousands. So the numbers are indeed staggering. I mean, we're talking about conventional data centers still going to maybe $12 million per megawatt or so, but right. This is only one component. If you add all the other elements, including land and power, and more importantly, technology, GPUs in particular, now the numbers more than triples. So
I think an interesting one. I think an interesting part of that too, Peter, is like as these legacy data centers are going to need to be uplifted into the new technology as well. So it's one thing building new, brand new, pristine greenfield data centers and using the new technologies for closed loop and how we could distribute heat. But we've got tens of thousands of data centers, tens of thousands of data centers out there. They're going to have to be retrofitted to use kind of this new closed loop cooling systems that you're talking about.
No, that's going to be difficult to do. Maybe some of them could be retrofitted to become inference or edge data centers. But
I think Mehdi has a few points on this too. But I wanted to ask Mark though too. When you did Edgevana, when you started it, was it right at the cusp of this radical change or right before? I recall it being right before. So I think you existed in this vortex for the last few years. Is that correct? And how did you guys survive it?
Well, Edgevana was not. It has
Mark?
a lot to do with
No, Mark, he's still muted, I think.
Sorry. Yeah, Roger.
Yeah,
Edgevana wasn't really started to build hyperscale facilities. We were started more to leverage access to global capacity.
Right. But what I'm saying is you started this in one era. I think in the era is, and you managed to get, tell us how you navigated through all that.
Yeah, so we started probably a couple of years earlier than we should have in trying to solve for the problem we were originally solving for, which is helping people gain speed to market in a global market for distributed compute, right?
But Mark, that's not what we started when we started Edgevana. That was not the initial model. Remember?
No, that was the initial model, Peter. It was to speed edge computing to the edge, to give companies that wanted to do their own edge computing in any real way, whether it was for sovereign reasons, data security reasons, true edge computing, CDN, to be able to give them access to thousands of locations around the world and to be able to do that distribution quickly, right? And that foundation turned out to suit us very well for the eventual future. But we ended up pivoting to support Web3 environments. And we did that because what we were building was literally designed for them without necessarily our knowing that up front. It was designed for them in the sense that they needed decentralized compute globally distributed. And by decentralized, that means they didn't want all of it to be on Amazon or all of it to be on Google or all of it to be in an Equinix data center or even 70 Equinix data centers. They needed it to be widely distributed and from different suppliers, networks included. And so
that's what I'm getting at.
Yeah.
How is that informing what you are doing right now? Then
So it's informing in a number of ways. One, it's informing to some of the same things we've been talking about, and that's the fact that power and capacity are on short supply globally, and building that foundation has helped Edgevana in a number of ways. But it also has informed us of the transition from what the expectations were in 2019 when we started versus what the expectations are now. When we first started, an edge might have looked like 5 to 7 kilowatts in a rack, maybe 10 max. Now it's a small rack at the edges is 40 kilowatts, and they go up from there.
So when we're looking at design, I have a question. We're going to let Mehdi summarize all this in a second, but before we get to that, I'd like to go back to Peter and then Greg and Mark, all three of you. You're all involved with IDCA on our boards. What is the organization doing? What can the organization do? What can we collectively do to sort of, I'm not sure if the word is corral, but to really get a good handle on what the pace of innovation, what it means and what it means for our audience and what it's going to mean for the world. How can we work with all this innovation that's going on? If you want to start, Peter, go ahead.
Yeah, well, it's a complicated process because now all of a sudden we're going to a architecture that is fundamentally different. It uses VAS and large storage, uses solid state transformers, uses maybe multi-port converter, uses new power electronics, field effect transistors, and silicon carbide and gallium nitride. We're going from transform from power infrastructure that is static hardware to software-defined hardware, software integrated hardware. It's as I said, storage is becoming a very important. Cooling, cooling has gone through such a rapid transformation, and it's not done. We're still, the next generation is going to be the microfluids. Microfluids that will bring liquid, we call direct to chip. Reality is not. Cooling doesn't come to the chip. Cooling comes to the heatsink. But the next generation cooling, it's not here yet. Maybe it might take another couple of years. But we're gonna have cooling directly to the silicon, and we're gonna have these GPUs with edge micro channels that will direct the cooling exactly to the points where the cooling is where heat is generated, and improve the efficiency of the cooling by as much as 300%. The things related to power monitoring, the way we design, the digital the new type of monitoring and controls, optimizing it through that. It's a brave new world. This is nothing compared to your grandfather data centers. So it's a very exciting. It's a very exciting time.
Or even your older brothers, Greg. As far as you're living this life, and you're the focus on security, maybe, but how is all this pace of innovation manifesting itself when you go to work in the morning, and what you have to do?
That's a big question. So I'll talk just a second about the security side of it, but as we've seen the AI and bad actors, and we've seen nation states, whatever, ramping up. It's ramping up at a pace that we've never seen before. Like, it's on the old hockey stick curve right now, coming up. And it's not just software. It's physical security now. It's now data centers are connected obviously through networks globally. So attacks you've got on data centers. It's also how they're using AI and technology to penetrate the buildings as well. But on the other side of how it drives every day, it's really the attack vectors are completely different. How they're approaching is completely different. And it innovates as fast as the computers and AI can think of it. Kind of tailing onto your other question there about how the IDCA plays into this.
Right.
I think it's helping connect the global players, which Mehdi's amazing at, right? In getting people to talk about this on the global stage, and how we're going to deal with power and how we're going to deal with data centers and AI on that. I think it's education and helping inform governments and policymakers in this as well, as to these new technologies, how they're going to play, because we're seeing a lot of news bites out there about, oh, there's a data center in my community, it's now going to be horrible, and like, how do these data centers be partners in these communities as well? There's learning programs. I think Peter touched on it, how schooling and engineering's going to change now for microfluidics as they come out, and how we're going to be moving beyond cold plate on chips and doing literally these microfluids passing through the silicon themselves for cooling. So I think there's programs and schooling there. And then there's also a role for all of us in the community on how we're going to play for government regulations and policy, because we do see sometimes those lag a bit, and then they seem to rubber band of, like, they go too far and too much, and then we fight for years trying to get it back to something that's financially viable for companies that are investing in this, that are great for stockholders, that are good for the environment, that are good for operators that run it every day. So that's where I see how AI is accelerating all of this, and how we've got to pivot much faster than we've ever had before.
Mehdi, if you want to sort of summarize everything we've heard now, I heard a couple of things. One, the sort of technical issue of retrofitting. I don't know if that's something we can address in depth here. But the other thing is, you're getting interviewed by people, and you're talking to people at a fairly high government level, which means in some senses non-technical. So how are all these great industry issues we're discussing? How does that manifest itself in the discussions that you're having when you're interviewed or talking to other people? And along the way, if you want to mention this whole thing of retrofitting, how are we going to accommodate this magnitudes of change in innovation, size, and
First of
scale?
all, I think Peter, Greg, and Mark, they touched on very important points. I think one of the biggest challenges we have in our industry is the ever evolving and fast evolving chip designs. And it takes you an average of 18 to 24 months to build a data center. And the chip is changing every year. And how do you even, investment wise, how do you not depreciate that asset before it's expired? And how do you extend the longevity of a data center by having such rapid, advancements in the GPU itself and the chip itself, whereas the data center isn't even ready by the time the chip has already evolved. This becomes even more complicated in the government sector because it takes you multiple years to get a budget to build a data center. And then by the time you even start building it, it's already obsolete. So this obsolescence and the fact that the infrastructure that you spend billions of dollars in designing and devising, building, operating becomes a liability for you. That's a major issue, and I think that's something that we need to as an industry come up with a solution. Which takes me to the retrofitting business. It is very expensive to retrofit. It's always cheaper to build a greenfield than to try to retrofit, especially with these new expansive developments which are not similar. So our past doesn't predict our future. And everything that is coming up down the line is not an evolution of the past. We're going from bicycles to airplanes. They're not the same. Therefore, retrofitting is becoming a very complex model, especially when you want to talk about high density deployments, HPC deployments. Sometimes you just have the absence of the capacities needed on the gray floor to even address the white floor. So having said that, when it comes to policy, and nations are now considering sovereignty as a major issue. How do you stay a sovereign nation? How do you build the right infrastructure within your own boundaries that keeps you a sovereign nation? The recent conflict in the Gulf War proved that data centers are #1 targets when it comes to conflict. So again, I joke about this. We used to tell people, don't build your data centers next to military bases. Now we say, don't put your military base next to a data center, because data center itself is a major target. So how do you build resilience? How do you build diversity across portfolio as a nation, as someone who's planning for a country or a region? How do you create regional cross-border, fix the cross-border, data transport issues? How do you create economic blocks around, different economic regions of the world? How do you create global alliances, data embassies? How do you ensure national security? If you become a nation that harbors data for your neighboring countries and other international firms, that's a additional national security shield that you created on yourself. Because if you become the Switzerland of having data banks in your country, then nobody wants you down. Therefore, that becomes another deterrence factor where you just have better national security as well as national sovereignty. So these are major issues right now at top of the table of everybody's conversation. Every president, every prime minister, every minister, even you talk to Minister of Economy, you talk to Minister of Defense, you talk to
it's not just one ministry, right? It's across the government.
Exactly. And there has been no ministry defined yet. That can address all of this in one go. So there has to be, a cabinet level involvement of everybody trying to come up with solutions.
So, Mark, let me ask you a question about energy. We have to switch over here to energy because now we just mentioned the vulnerability. Don't build anything important near a data center because it's become a project. Well, you also have to feed that data center with energy, which is another possible vulnerability. All that said, what are your views on how in the US and the world, governments and businesses and organizations can develop some of the energy that's going to be required for all this, easy question. I'm sure you can answer it.
Yeah, well, I mean, Roger, there's a lot of different ways to answer that question. I mean, from the simple notion of, what's fastest to get.
Right.
And if people want to read more detail, I actually posted something on my LinkedIn profile
Okay.
about this.
Yeah.
What's fastest to get versus what's easiest to transition from versus what
Right.
offers the best long-term flexibility. There are a lot of different choices that go in. Right now, most people are worried about speed. And the one thing I will say, this is sort of a little bit outside the lane, but to Mehdi's point about brownfield, the one thing I will say that's positive about brownfield is it already has a permit and it already has power. And that's literally what everybody needs right now. They need permits and they need power. So if you can find energy someplace that's already available and permitting for building a data center, it doesn't matter what's there. It's kind of like, for those of you familiar with high rent areas like Palo Alto, California, it doesn't matter if it's a 1-bedroom, 1-car garage place, you still pay $2 million for it because you're not buying the house, you're buying the property. And so that's extremely accurate when it comes to energy these days. I would say, natural gas, generally speaking, still wins. And I don't like to say that, but it doesn't matter what I like.
We have to be practical here. This is the thing. We know what we like.
Yeah, natural gas wins mainly because everybody's comfortable with it. Everybody understands the ramp schedule. Everybody understands the overhead associated with needing, 33% extra, give or take, in order to make sure that you have turn on and turn off capabilities.
Even these big turbines, their price has gone up 2.5 up to $2.5 billion a gigawatt now, and you can't get your hands on one.
Right. No, it's absolutely true. And which is why wind and solar and BESS have become so popular in the last couple of years. And they are the most natural is not a pun, most natural alternative to gas. The thing with the cost though, Roger, is that what a lot of people are forgetting, and that's part of the point with the brownfield discussion, what a lot of people are forgetting is that if you're deploying what we're talking about, which is high density AI type compute, meaning, somewhere north of 50 kilowatts a cabinet up to hundreds of kilowatts a cabinet.
Right. That's what we're talking about. Yeah.
Then you're talking about companies that lose somewhere north of $10,000 a day per megawatt in non-deployed load. And almost you talk to almost every single one of the companies out there, CoreWeave, TensorWave, those are the neoclouds. You talk to the big players, OpenAI, Anthropic, every single one of them will tell you, if you have space, we'll take it right now because we have load waiting to be deployed. So when you throw permitting or when you throw cost of gas, whatever the piece in the equation is, you have to measure that against what the lost opportunity is.
Okay.
And at $10,000 a megawatt, even for 100 megawatts, that's an enormous loss.
Let's ask a couple of questions here. Now I want to ask Peter. Peter opened his can of worms. He started talking about the physics and all the huge engineering problems, outlining in exquisite detail what the problems are. And so now let's do a couple of questions, and then I'm going to ask Peter about energy, about what he's seeing, as the current state of what we should be doing. So if our producer could throw up question number 3. Which region do you believe will experience the fastest data center growth? Speaking of the energy concerns that are coming. Now, the US right now is 46% of all data center consumption and capacity in the world. And China is a big unknown. Even organizations like the World Bank are off by a factor of 5x in their estimates. They range in a factor of 5x. We've come up with a number that we think is pretty reasonable. But the more important issue is that China has an ability to put their foot on the accelerator and start catching North America, or especially the US. So let's see what the answer to this question is, where people think the growth will be. Okay, if you look at the dominance of the US right now, and then you compare that to the answer here where the Middle East and Africa, and I'm going to guess that a lot of this is really the Middle East, because that's what we're seeing at IDCA too, is there's going to be a lot of growth in the Middle East, and maybe we can talk about that a bit. Let's throw question number 4 up there. And Europe, as you see, is not very active, according to what our audience is saying. When it comes to security, should governments classify data centers as critical national infrastructure? I believe this has already happened in the UK, and it may be something that we could certainly see in innumerable other countries in the world. In the United States, even, we're a little more federated. It could happen at state levels too, as far as not national security, but essential infrastructure. But let's see what people think if it should be classified that way. Yes, 74%, 3 out of 4 thinks that all data centers should be classified as critical infrastructure. That's a huge answer. And you see that 0% have said no. So maybe we can get to that in a second. But before we do, Peter, how are we going to solve, what should people do for energy right now, whether in the US or other parts of the world? What are you seeing?
Well, I think that we are going through a transition phase. We are at probably the worst period when it comes to energy. The grid in this country and in Europe and other places around the world is stressed to the limits. The utility grids are aging, and in the same time, the amount of additional load is imposing some really very difficult conditions to this grid. But in the same time, because speed is so important, like Mark mentioned, on-site generation is gaining rapid acceptance, and is projected that between 30 and 40% of all new data centers between now and the end of the decade will have some form of on-site generation.
Wow.
If you look at
that's a big number.
Look, the largest data center in the world today is in Abilene in Texas. And that uses a combination of utility and turbines. We're talking about 1.2 gigawatts data center, and there are on the books at least 20 other projects with similar sizes or larger. So there are ways to. There is still capacity on the grid and some creativity there. Flex load is one element that people should consider, and SB 6 in Texas is a good example of that, where the utility imposes a mandatory off-grid requirements for any data centers exceeding 75 megawatts. When I'm saying that we are in a transient period, is because in a few years meaning early 2030, we're going to have SMRs. We're going to have 5 years later, we're going to have probably the ultimate solution, which is fusion. And there are all kind of other interesting technologies out there. There is a shortage of turbines and recips. It takes a long time, but the reason, and I think that's going to be another topic to discussions here. Fuel cells, particularly solid oxide fuel cells, are gaining such a rapid acceptance, not only because they're reliable and they can deliver the power, but also the fact that as opposed to combustion type power supplies, fuel cells don't generate fumes and smokes and emissions, and they don't consume water. So that becomes a really important factors in today's environment when there is the data centers are under so much pressure. So there is a whole slew of geothermal is gaining ground. White hydrogen is an interesting solution. Linear generators. It's extremely exciting to just look at what's happening around, and we should not mention, especially when considering renewable storage. Storage is enormously important, and all the progress made in storage, and that's another discussion, and it's going to take time.
One thing I wanted to mention, we will pause for 15 seconds while I deliver a commercial. We have reports, and actually they're free. They're complimentary, available to anyone that wants to receive them with all of the data. Everything we're discussing here, we're looking at the big issues. We're drilling down into some of the specifics, but there's also a lot of data that we're not discussing. But in our reports, we have a data center report we put out a couple months ago. We have a energy report that's going to be coming out very soon. We have a digital readiness report that's comprehensive nation by nation, where we have all the data that's actually informing, underlying all of this conversation. I just thought I'd let everyone know about that. And I wanted to ask Greg a question. Before we get off of energy, we still have other things we want to cover, but energy is so important. I wanted to ask Greg, this idea of data centers becoming more vulnerable and having to attach copious amounts of energy to them, is that tangential to what you're doing day to day, or is it affecting it now, or will it affect it soon? What are your views on what you've just been hearing, Greg?
I think we're still evolving in that space. It's becoming a critical part of the infrastructure and the asset that you've done there. And I think we're just now really starting to peel the onion and understand the exposure we have there to the grid. Peter was talking about, and there's some fragility in it, being overtaxed in certainly some parts of the country, where before it would be just like, well, bring in power from two different locations, or two, if you can get a couple of substations going, fine. Now it's diversity beyond that of different types of power solution, and having redundancy in there, because they are becoming, I don't want to use the word easy targets, but they're not generally inside your fence where you've got direct control. So you can do that, but certainly the city town infrastructure, whatever, becomes much more of a concern in what they're doing on that side as well. So yeah, it's one thing to protect and harden the data centers themselves. We've got to start looking a little bit beyond your own fence line and what's being done there. Because if we've had it be, everyone who's worked in data centers has always had a substation go down somewhere in their career, and then you've had to deal with, how do you reroute power around that? As larger and larger power volumes come through them, they become much more critical as we're going on. So it is definitely changing, and I think is going to continue to evolve. And as the different technologies that Peter was talking about, I think we've got to play in mind of how those are going to be hardened and protected as well. Everything from the, bring your own power that he's talking about on site, that becomes a whole other engineering problem and possibility dealing with those. So yeah, it's something we're definitely thinking about, but I think we're in the early stages of learning what it really means.
Now, Mehdi, when you're going around talking to people, you have to tell them the bad news, on energy. How are people reacting, and what are you saying to people to have them on a national basis, get their digital sovereignty, get the infrastructure they need, but also get the power? What are the issues as you see them?
So when a country wants to plan for their digital readiness, typically what they do is they look at where they have the available power. What we tell them is go after where the potential power is, not where you have the existing power. Because if you look at the national terrain of a country, you take any country, what they have today is what they had planned for 2 decades ago. And that was not with AI as a factor. Now, with AI being a major extender and expander of the digital economy, all of a sudden, everything will change. Therefore, you need to go after areas where there is potential for greater power than what you think you have available today.
Yeah.
So forward thinking is very important. I think nuclear is a very important topic. And I think European Union is going towards nuclear more and more, because that is they are now being driven to become more independent
Yes.
of the recent happenings. So I think they're all going that direction. So yeah, that I think SMRs during the transition, and then later, full all-out nuclear is one of the most important topics.
Now,
talking.
I just mentioned our reports. We need to talk about workforce development, and I'm getting yelled at here in my messages. I have to make people aware that we have something called the IDCA Global Foundation, and the CEO of that, Dr. Simona Marinescu, is watching this webinar, and she's telling me, make sure we mention workforce development and also the Human Dependency Index. So we are also in our organization focusing on all of the data that's involved in the programs involved in workforce development. So with that said, Peter, you're there. I see you prominently here. You know, this has changed too. It's not your dad's or grandfather's data center where you train people, as IDCA has been doing. What about modern workforce development? How is this manifesting itself in terms of what companies have to do and nations have to do?
Well, this is a huge problem. I don't think that our industry recognizes the magnitude of this problem. You know, Goldman Sachs came out not long ago, and they said that that the AI industry will need for the next 10 years to add 300,000 electricians. And this is only electricians, doesn't include other trades. And that's on top of the 200,000 electricians that will retire between now and then the end of the decade. So the numbers are absolutely staggering. If you come to think, you know, let's take commissioning, because commissioning is enormously important in any kind of data center development. So right now there is a shortage of commissioning agent, and there are relatively few new data centers that are being commissioned. Imagine what's going to happen 2 years from now when you're going to have 50 to 100 new data centers, large data centers being commissioned. The shortage of commissioning agents is going to become so glaring. Imagine what's going to happen when you're going to have tens of or hundreds of AI factories where the shortage of operating personnel is so acute that will really create significant problems in running this very complex operation. As I mentioned before, digital twins might help with the operation, with training, but unless we have a industry-wide consensus of the need to train people, you know, this is a fairly sophisticated industry. Having the ability now to cross over the barriers between facilities and white space. Historically, these were totally fundamentally different disciplines. You know, inside the data centers, the people did rack and stacking and maybe working at 120 volts. And now all of a sudden, they're going to be exposed to 800 volts DC. They're going to be exposed to liquid cooling and mechanical system there. All of a sudden, this barrier disappears, and we don't have people that have the ability to operate on both ends of this spectrum. So it's becoming enormously critical that we address this problem. And my concern is that we don't take a lot of steps. There is not, you know, IDCA is one of the very few organizations that take a proactive role in doing this kind of education. But you know, the need is going to become so glaring in a couple of years that this industry will be really hurt if we don't do more about this.
And so thank you, Dr. Svoboda, for making sure that we address this in the depth it deserves. And as Peter was talking, I'm watching Mark shaking his head yes. So Mark, what are your views on what Peter just said? And what can IDC do about it? You're muted.
Sorry. Yeah, there's certainly nothing to argue with in what Peter said. I agree with all of that. And I also agree with that. You know, IDCA is one of the few organizations that is helping the industry at any reasonable scale to try to solve this problem. But I still think we don't just have a gap in overall scale, right? We can't have 10 or 20 organizations around the world doing 1,000 people a year. That's throwing peanuts at elephants. That's not going to help, right? We need something bigger. And to me, bigger isn't just cooperative. I think cooperative is an opportunity, certainly, but I think bigger means that we need to search outside our comfort zone for the type of people that we recruit and bring into the industry. Because most of the training, at least in my experience, most of the training, IDCA and others, is focused on training people that are already data center types.
Yes, but you're looking at a massive expansion in the number of people and the skills that they need to have as
Well,
well.
that's right. So yeah, not only do we need more people and more skills, but we're still focused on retraining or training people that have already made a decision to be in the data center world.
Right. Self-selected.
And we
Yeah.
have, you know, a million person shortage by the end of the decade, that isn't accommodated in those numbers.
Yeah, Mehdi, what is your thought on what we've been discussing in here? What is the nature of the challenges we're working on a day-to-day at IDCA and at the foundation?
Well, because we're a very human-centric organization, we always believed in the value of workforce and workforce development. And I think education is paramount. But like Mark said, you need to educate them and give them the skills and toolkits necessary, but also put them into a workforce. One of the biggest challenges we have is because there's a big power play behind the data center industry. People are going to areas where they're fairly remote just to get the power, and then getting people who have, basic standards of living to go to certain areas is very difficult. So how do you convince these people in the remote areas of the country and around the world to get into the data center industry? The entire screening and advocacy part is one thing, which takes us back to the community engagement discussion we need to have. But then training them and putting them into the workforce. What Peter mentioned about the deficits we have, it's huge. We have millions of people shortage today. And
Yes, our research shows that.
these millions will not come from the existing workforce in the industry. They have to come from
Yeah,
fresh graduates, even people
that's
who
it.
have never been to a university. It doesn't matter. You don't need to have a college degree to work in a data center. You just need to have the skills to work in a data center, depending on what you want to do up and down the ladder. So I think professional education is the key. What we're doing is essential, is critical, and we're doing it at regional levels, national levels, and countries are coming up with workforce development programs as part of their national agenda as well. So it's something we're very keen on doing, and it's
So Greg, real quick, we were talking for everyone, before the thing started and about generational aspects of this. So we have a lot of experienced people, but now we also need to start training new generations into all of this work. This, again, maybe doesn't manifest it to you, Greg, on a day-to-day basis right now, but I'm sure you're thinking about it. So what are your thoughts on this topic?
Yeah, you're right. Maybe not day to day, but it is one of my passions, I guess you could say.
Yeah,
With kind of, I have a couple of grandchildren now, and I've got,
yeah.
my lovely daughters and son.
So
So,
we think of the future. Yeah,
so thinking of the future exactly about how do we get into these schools, how do we get into the programs,
yeah,
whatever, to say that this explosion that's going on in technology isn't just we need millions of AI developers and stuff. I think, as AI develops, it'll do more and more of the coding, but these fluidic engineering programs, electrical
Mhm.
engineering, mechanical engineering, how do we get those being attractive programs that people want to go into, and how do they play into the future, and that they are going to be dynamic, they're going to be needed, they're going to be interesting, solving very technical engineering problems that we don't have. Peter was talking about, microfluidics passing through processors and stuff as we move away from cold plate cooling and stuff. People to solve those problems, build those, deploy those, like these are going to be complex, interesting engineering physics problems that we have to solve. So how
Yes.
do we get early on in the programs to do that? So, speaking at schools, speaking at universities, kind of talking to the local, senators, how do we influence programs around that? I think that's a role that we all have to play as some of these senior leaders or people that have been this, of like, how do we get that interest going in the younger generation? That it's like, I'm going to do my startup, sell it for $5 million to some company, and that's how I'm going to get rich.
Yeah.
Like, how do you get involved in these engineering, let alone, electricians? Like, even just trying to find an electrician to build something onto your own house, let alone finding the level of the electrician that Peter's talking about.
And all of
It's
the
going to
stuff
do, yeah.
that Peter was mentioning on the innovation. We have 6 minutes left, and we need to talk about community pushback, community efforts, what's going on. I think everyone's aware of some of the initiatives that have come up, and also in lots of places where the developers have engaged with the communities and successfully gotten their projects approved. But before that, let's finish the questions, and then we're going to do the best we can to address the community issues. I think we're on to question number 5. I think we have 3 more to go. What is the most important factor when selecting new data center location? And here's a whole topic that we're going to need to have another webinar for. But let's see what our attendees think about this particular issue. I'm gonna guess what the answer is going to be. Not out loud.
Yeah, we all know what the answer is
We
going
all
to be.
know what the answer is going to be. Let's not tip the scales, though. Let's see what people say. Okay, that'll come up here in a second. Yes, power, number 6.
Yeah, well,
The clock is ticking. Which emerging technology will have the greatest impact? Okay, I think we know the answer here. Now, SMRs, we talked about, again, another topic for a webinar. If we could just go to sleep for 5 years and wake up, a lot of these issues may have played themselves out, but the hard work is what we're doing right now, is to make this happen. So I think we'll know what the answer here will be.
I know, I could see those
SMR is
spread out.
important. Yep, AI. And number 7, I'm sorry?
I was going to say, I could see those spread out because those are all very interesting ones. So.
Well, we make you only choose one, and the thing is that all of these issues are important. And if we said, well, select how many you want, they'd all select them all. So we're forcing decisions here. How prepared is the global data center industry for the AI era? I would say somewhat, but I don't want to tip the scale. There are a lot of serious people actively engaged, but somewhat. Very good. Very good audience. Okay, community pushback. Mehdi, very quickly, let's lead this discussion. What are we seeing at IDCA? What are you seeing? What are the issues, and what should data center developers be doing about it?
I'll be very brief. This can have its own webinar all by itself. First of all, it's a fact that our nation and many countries around the world are great and our infrastructure is rusted. So with or without data centers, we were hitting the dead end very soon. So a lot of problems and the stress we see on the water and on energy and everything else is not because of data centers alone. It's because we have not invested in modernizing our infrastructure. That's problem number 1. Problem number 2 is people think that data center industry is secretive and they're hiding things from them. But we have to understand the nature of the business. Power is scarce. It's almost impossible to find the power land these days. If somebody get their hand over a piece of land that has power, they can't publicly announce it until a transaction is done. Otherwise, their competitor will take it. So it's not intentional. At the same time, can data center companies do more? Yes, they can. They need to spend a fraction of the money they make in empowering communities and having this communication and create those awareness and have those collaborative sessions with the communities. And a lot of stuff that you see, the brown water and the jar and all of that, a lot of it is misinformation, which we as an industry need to come together and provide the right answers to educate the communities. And I'll let the other
Yeah, Mark, we'll close. We're going to let Peter have the last word, but Mark first, and then Greg. You have 1 minute, and we're not taking this issue lightly. So, but we do want your thoughts on it.
Yeah, so I would say, the simple truth is most people, when asked, would you like to live next to a data center, even people in the data center community, no one raised their hands. So that should tell us something. Don't listen to people saying that it's from China or it's from Russia or it's bots.
The pushback, yeah.
And please don't use the word pushback on the community, because that doesn't work, right? Engagement works. Transparency, as Mehdi talked about, works. We don't need to have NDAs that allow us, and in some cases, even the local city councils, to cover or lie about what's coming before their citizens have a chance to vote on it. There are simple ways for data center companies to engage with communities and provide give back at a volume that would surprise them and mean almost nothing financially to the company involved. And my recommendation is to get involved early, be open, be collaborative, listen, don't try to push push what you believe are facts on people. Just engage, listen to what they need, and find a balance that you're willing to give that you can support financially.
I'm going like this, Greg. 1 minute, and then we're going to run 1 minute long, but I think our audience will hang in there with us. Greg, what are your thoughts on the community dialogue and teasing out the issues and really what companies should be doing?
Yeah, it's hard to add on to what Mehdi and Mark already said, I think. So I'll just kind of plus one in the fact that it's early engagement and communication. There's a lot of misinformation out there. And I think we found over the years, as you engage and discuss and take these hard questions up front and get them and start to make them feel heard and make them feel that their concerns are being at least addressed, it always smooths things out. So, but I think Mark and Mehdi covered it really well.
Okay, thank you. One thing I'm going to have to mention, and then we're going to let Peter have the last word, which is that IDCA and the Global Foundation, I'm being reminded here, are actually actively involved in what we're calling the Global Policy Dialogue with the United Nations, with the group, the Sustainable Development Goals Organization, SDSN, and also with groups in Japan and in other parts of the world. So we are involved in this at a high level. We encourage everyone to engage us about that. We also encourage everyone to follow up with all of our panelists today with the questions that you have. Clearly, an hour is not enough time to cover everything that we wanted to. With that in mind, all of the dialogue that we've just been talking about that we should have. Peter, what are your views on that? Like I said, we'll let you have the final word.
Well, I don't want to sugarcoat this. I believe that this is an existential threat to this industry. I mean, we cannot take this lightly. And the reality is that the industry, the data center industry in general, has not done a very good job. Individual data center providers have their own strategy to address this issue, but I think that the industry has to come together and put together a consistent, cohesive answer to these issues. And these are all valid concerns. It's not that this industry is not ready to address this, and also let's make a clear distinction between conventional data center, where concern is more about the cost of electricity, water, and noise, and data centers that have their own on-site generation, which is a much more complicated and difficult issue to address, because indeed, nobody wants to live next to a data center, but really nobody wants to live next to a power plant, which is so.
But yet, but we're advancing the 21st century economy here. Mehdi, if you'd like to close out today, that would be great. And I wanted to thank everyone, our panelists, so in advance. Thank you so much for coming. We could spend hours with each of you. Thanks to the attendees. And Mehdi, take us out.
Just one last thing about this conversation. I think one thing we have to always keep on reminding everybody, we as the end users are the ones driving data centers, drawing them closer and closer to us, because we are the ones using ChatGPT. We're the ones using social media. We're the ones drawing the bandwidth. So our consumption is driving data centers. Data centers are just a mean to a goal, which is serving our needs. So that's number one. Number two, everywhere data centers have gone, they've served the economy and they've empowered the economy. Look at Loudoun County, one of the poorest counties in the United States, now one of the richest, giving tax rebates to their citizens. So there is a lot we can talk about this. I think this was a very important dialogue. I think we need to do more of such dialogues. And all of these topics we talked about, they deserve their own conversation. So I think this was a good high-level conversation, and we can do deeper dives in the coming future. Thank you, everybody.
Thanks, everyone.
Thank you, everybody.
Mark, Greg, Peter, thank you very much. Audience, thank you.
Thank you.
Thank you.